Right. Well, first of all, thanks for having me. It's great to be here, if not virtually. My focus is going to be on what's important now as we move into the world of machine learning and AI. And I think what the most important thing is to understand all of those resources that Oracle has to help you in this journey and where they've implemented things in the various algorithms or the math behind some of the things. Some people think that machine learning is analytics, and it's not. It's nowhere near analytics. If you think of a self-driving car, they're looking at images with a TensorFlow with 1,000 cats, and it automatically figures out what a cat is based on that, based on mathematical algorithms that have broken the picture up and learns things that you don't have to learn. Uh, Not the same as analytics. Instead of maybe thousands of transactions or even hundreds of thousands, it's billions, hundreds of billions, even trillions of transactions to come up with that. So keep that in mind. If you want a copy of the presentation, here's a way to get it. You could always just send me an email. You'll see it at the bottom of the slide. Slides from time to time. That's my Twitter, where I tweet things from time to time. Work for a company called Viscosity. Nice to have 4 aces in your back pocket when you need them. And we do, just to give you a background, we do a little bit of database, a little bit of things like Apex and applications. Then we do infrastructure, not just Oracle. We'll do Amazon, we'll do Azure. But the goal is, as I said, focus on what's important now. As we look at machine learning, what are the products in Oracle that you can leverage currently? What are the products in Oracle applications that already leverage those things? How about big data? How about IoT? And then things like AI and chatbots, robots, where are those going? But the first thing you have to remember is you're in a very innovative and disruptive time. If you listen to Gustavo, I thought something great that he said is the cloud is here to stay, and focus on innovation and automation. Machine learning gives you that focus. We're moving from this area of using digital, then we started wearing digital. Now we're starting to implant digital. And the hive mind, we're using it right now. Future of implant technology. I mean, if you look at this guy in the upper right, his arm is his job. We thought Edward Scissorhands would never happen, but if this guy decided to be a barber, it would be Edward Scissorhands. Service robots, you see them everywhere, whether they're taking your order, whether they're checking you into a hotel, whether they're checking you in for a meeting. They're there to automate certain things. Now, if you work in a company and you're alongside robots, that makes you even more important. But it is time for workers to worry about AI and understand exactly where they fit into that process. Innovation is something that's new or different. It's not reinventing the same thing. Why are companies going very fast and doing very well? They leverage IT, they leverage big data, they leverage chatbots, they leverage robots, they leverage things in AI like machine learning, leverage IoT. They leverage all that data to deliver their product or understand their customer or offer a product better. Here's some other disruptive innovation examples. Postal mail went to email, telegraph went to a telephone, then a cell phone. Floppy drive went to a USB, encyclopedia to Wikipedia, filing cabinet went to a database. But then email all of a sudden was text, Snapchat, Instagram. Now I just send you a picture. USB went to Google Docs maybe. Wikipedia went to Alexa, Siri. DBA starting to go to autonomous database to offload some of that work so we could focus on the most important databases that are out there. But it's not the same technology. You have some technology, let's call it a telegraph for a while, and then the telephone comes out and you really can't use that telegraph anymore. It's in the later stages, no amount of investment in that telegraph is going to help you. But I look at innovators that are out there. It's not just technology. Apple, what kind of innovator are there? And you have to look at your company. What kind of innovator are they? They're a tech innovator. Somebody like Amazon is more started with books, then they went to movies, and they start having an innovation day. Shows you that they focus on that. Instead of Black Friday, they have a Prime Day, their own day focused on them. But they're a retail innovator. Google is a marketing innovator, doing things to help, through search engines. They found a lot about people's buying habits. And then they started getting into algorithms a lot. And so they built a product called TensorFlow that did image recognition. So they could look at 1,000 pictures of cats, as I said earlier, and they know what a cat looks like. So that the car, when it's driving down the road, it says, don't hit that cat. Don't hit that thing identified as a car or a person. And hopefully it works better than on Total Recall. Google's data center, it's all flash. Look at Facebook's data center, looks the same, all flash. Having things in memory and very fast is very important because we're no longer looking at thousands of pieces of data or thousands of transactions, it's billions, maybe even trillions, depending on how big your company is. Oracle's focus, though, is they're not a retailer, they're not a marketer, they're somebody who builds tools for you. They want to make you the best marketer to compete with an Amazon, or the best, or to compete with a Google, or the best retailer to compete with an Amazon. They give you the cloud, they give you the data, they give you the apps, they make it fast. Most importantly, they give you security. Not many give you that. And they start doing machine learning. But if you look at Larry, he likes leaders, risk takers, people who do things before they become fashionable or popular. He's saying, I like innovators, even though I didn't know he was saying it. Talked about the cloud and how fast it's growing. If you look at Oracle's numbers, they've been growing very fast in the cloud. And then Oracle also bought a company, data science company as well, because they see data science as a way to develop that competitive advantage. They put it inside their Oracle applications. I'll show you a few of those. And keep in mind, this is just exposure to some of those things that are out there. They've also given you access where you can access all the algorithms yourself with machine learning through the autonomous database. They also bought a company called Data Science. They also, a fourth one, put it in Oracle Applications Cloud, which originally was Oracle Analytics, but they put an extension on there to access algorithms as well. If you're a DBA, is it replacing you? Is the autonomous database replacing you? No. But keep in mind, a robot may not look like one. Siri, it's a robot. Alexa, it's a robot. They never complain, work 24/7. Autonomous database, it's a robot. Manages the database for you. Self-managing, self-securing, self-tuning, self-recovering. As a DBA, you should love that, because now you could take your lesser important databases that don't have to be watched so carefully and make them autonomous, and you're able to manage many more and much faster. Puts the patch on for security before you even know that you need a patch. How great is that? Upgrades it to the next version for you. So you don't want to be like a telephone operator where you want to keep doing your job when a switch replaces what you're doing. You want to work alongside that automation, because the person that's working alongside all of those robots becomes very, very important. So what do I think you need to do? I think you need to drive closer to the business and innovation, which is interesting. Me and Gustavo didn't get together, but we both are saying the same thing about innovation. It's very important to see what the business is doing and apply that. You'll see in machine learning, the most important person is the DBA. I'm going to show that on a graph later. Why? How hard is it to use an autonomous database if you've never used one? You build one, it takes all of 3 minutes. This is 18C, and then it'll upgrade it automatically to 19C for me, but that takes about 3 minutes as well. Just go to cloud.oracle.com/try it. You try things like Kubernetes that you saw in the last talk. Try things, like big data, IoT, other types of databases, NoSQL or MySQL. Sign in, create a data warehouse, create a database, be autonomous transaction processing in this case. I either bring my license or the license is included. And I pick either transaction processing, data warehouse. It also has autonomous JSON now. A lot of growth there as well. ATP up in 2.5 minutes. If I want to scale it up, it's very easy to change the cores or change the storage. If I use a cloud like Amazon, I might have to jump to a bigger server, take everything out of one and put it in another one. But with Oracle, I could just scale up and I can go all the way into the petabytes. Stop it. I just click stop. Bam. 2 minutes, it's down. 2 minutes, it's back up. Now, if it's a larger system or you haven't used it in a while, I've seen those take longer. The focus of this talk, though, is going to be looking at machine learning. And the key processes are, do you understand the business? So before you do anything, what are we trying to accomplish? Then notice the next step, data understanding, data preparation, modeling. A lot of the things have to do with data here. And then I start building the algorithm and deploy. We'll see the time it takes for each of these. The largest piece of it is in the data side. And that's why the DBA is so important. But Oracle has all kinds of different algorithms, and they fall into different functional categories. So the function is classification. I want to classify these customers maybe into good and bad customers. But I have, notice, 7 different algorithms that's underneath here to do that in. I want to cluster them into maybe age groups because it's big data and I want to market to a certain age group. And then within that, I have 3 different algorithms. And you'll see in 21C, I'll show at the end, there's a couple additional ones in anomaly detection and classification. Anomaly detection, I'm trying to find that outlier. Time series, sales are more maybe around Christmas. Regression, you say, well, with analytics, I can do regression. Well, linear regression, but more complex regression is a little bit harder. When you go to billions of rows, Exadata comes in handy. Attribute importance. I want to find what attributes makes that my best customer so that I can go to big data and find the exact same customer. Association rules. What are people buying together? Bread, milk, eggs. Then things like predictive queries, SQL analytics, text mining support. These are all things Oracle has been building for many, many years in statistical functions. Then there's also the category feature extraction, extract certain features to simplify the problem so that it runs much faster. Now you could do things in R, you can do them in Python, or you can do them in SQL. We'll see with Oracle. And that's one of the advantages of Oracle. But be specific when you start out on the business understanding, when you're trying to find out exactly what is needed by your specific business. It's not target the best customer. It's what makes them the best customer. Is it how much they buy? Is it where they are located? Is it how often they buy? Is it the seasonal aspects of when they buy? Is it how much profit they give me? Whatever those things are, you're building that and separating them. And then, as I said, there's many algorithms with each function. I may be able to test all the algorithms and compare them to see which one is the fastest. And we'll see how Oracle has made that even easier. Some of the syntax I'm just showing you so you get a feel for what it looks like. You're not going to learn all this now, but you can take this these slides, which I'll give that they can give you to look at later. But here's creating a model. I'm giving it a name. I'm going to a certain table, certain columns. And I have a settings table, and that's where I'm going to call that algorithm. And here's just a little detail on that. But it's easy to see an example. So here I have a settings table here, and I'm saying use a certain algorithm, support vector machines. And this is just some math that mathematicians have built over 50, 60, 70 years to do some certain type of math, and they've perfected it over time. And here I give it a function name. What am I trying to find? What are the attributes that are important for this customer, that this cust ID from this table, customer insurance LTV, that will buy insurance? What are the attributes of those great customers that are buying insurance? So that's the model. Then I go to that model and it tells me what they are. Now, some attributes, bank funds may be, 95% of the deal. Some of the other four might not be as important, and I need to find that out. But very quickly, see how fast I could find this out if I have the right data. Now let's go one step further. Instead of attribute importance, let's do classification. And now that I know which attributes are important, I'm going to go to this same table and I'm going to say, will they buy insurance? If, give me the prediction that they're going to buy the insurance, yes. If I use those things like bank funds and all those attributes that I know are important, or maybe I'm going to go to big data once I find the fastest algorithm and the one that tells me this, and then I'm going to run it. Well, first of all, you should notice that if you're not a data scientist, wow, everything was SQL. It wasn't very hard at all. That's what you should find. Now, the hard part is there's a whole lot of algorithms and a lot of different functions. You have to understand what those are. And the names of them are not these, they are close, algo decision tree with underscores. The other hard part of it is there's many settings. There's different settings that I'll give for a given algorithm to tweak it for my given business problem that I have or my data that I have. So as you look through the various algorithms, you're going to look at those things. A couple other algorithms to kind of see how the math works. The math is saying, give me a circle, put all the dots inside the circle, and anything outside is an outlier. What am I going to use that math for that has built this tight circle as tight as possible to find the outliers? Maybe for fraud detection or certain anomalies. Or this is a different piece of math, also known as an algorithm, that says separate these dots, not by the green line, not by the blue line, but the red line that shows my good and bad customers, so that when I go to big data, I know if they're going to be good or bad, called a linear support vector machine. The anomaly one was a one class support vector machine. So I'm just looking at one thing. So I can go to autonomous transaction processing. Remember, it took me a couple of minutes to start it, 3 minutes to build it. And I can go to now Service Console and click on that, and I'll have machine learning notebooks. And first of all, it has all this information on how to do it. I could learn how to do it, or I could just jump right in. I could run a SQL statement, select star from tab, run SQL scripts, go and build a notebook, which is a listing. Think of it as a page that could be 100 pages long of SQL statements and SQL scripts, SQL, PL SQL, could be Python, etc. And those are called notebooks. And then also has examples. I don't know how to do this at all. Oh, I could just go in and click on one of the examples, see what anomaly detection looks like, see what it looks like for association rules or what people are buying together, see how to find which attributes are important, see how to cluster data into groupings and so on. And I could see that in SQL or Python. And here's a notebook and how it looks. So now remember, I had a quick statement. As I said, you're not going to learn it, but get a feel for it. Create a model. Let's see how hard it is. Built a little PL SQL. Create a model. Here's the name of it. Classifying data. Go into a table, customer 360 by customer ID. And the second one, I'm not looking to see if they're going to buy insurance. I'm just looking for null. That means I'm looking for anomalies. And then which anomaly detection algorithm am I using? Support vector machines. Now I can go and I can click, that was the grid. Now I'm going to click on graph once I see these results. If I see just, the tabular way is the far left. But now I'm going to click, I can do a pie chart. I'm doing a bar chart here, obviously, right here. Clicked on this. And I'm looking at whether they are anomalous customers. And I'm looking at the household side, years of residence, things like that. And then under settings, I specify what I want that X and Y to be. This is anomalies, and I think this one was years of residence, but you do whatever you want. Now I'm going to do it in a tabular way. I'm clicking this one, and I'm looking at the prediction that it's an anomaly. And this is how I say it's an anomaly based on this model. And it gives me the most anomalous customers. And then I can go one step further if I'm good at SQL. And I can say, give me the attributes that are making them anomalous. So you can see there's something you have to learn here, some of these predictions, but very quickly, most of the job has to do with understanding SQL very well. Keep that in mind. So now I've found the attributes that are making them anomalous. So you're not going to learn it here, but you go through a few of these notebooks and you'll say this stuff is very easy. And I already know 95% of it. I just never knew I knew it. And a data scientist is making twice as much as me. And the hardest part is what I know. One other algorithm I'll show you quickly, decision tree algorithm. Maybe it's a court case. Perry Mason maybe is a lawyer. He wants to see, should he take this settlement of $30,000? Well, he's put in all the cases he's ever done of this type. He's built a decision tree to see if he proceeds. There may be costs, there may be damages, he may win certain levels, but it will calculate all this for him and say, overall, you're going to lose $2,500. So he knows he should take the settlement instantly with this decision tree algorithm. You can put something like Apex in front of it to make this very fast and very slick looking as well. It won't make it fast by putting it in Apex. You can very quickly put it into Apex and make it very simple. It could even be on your phone. Here's another example Oracle has shown you. Notice this is not in a notebook. This is just in SQL, but it could be in a notebook if you wanted it to be. You could place this in there as well. Here's one where I'm building that decision tree to decide whether I should take this case. But in this case, I'm going to do classify whether a customer is going to buy this logo of maybe my favorite sports team on this credit card. And then I do this select, do a prediction, and find out what the probability is. So maybe I go to big data and I say, well, I don't want my salespeople, if the probability is very low, I don't want them going after those customers. I want them to go after the best customers, or also known as the Glingberry leads. And there you can see all kinds of different SQL examples as well. And you could just search for this on the web and see some of these. But as I said, machine learning is vast, and you have to look at what are the pieces that matter to your company, to your situation, to the problem you want to solve. You know, you want to solve and find a cure for MS. You could do that by using the machine to do things for you. You want to solve and find a cure for cancer. You can do that by using machine learning to do that for you. If you understand the other pieces that you're looking for. But it could be supervised learning, means you have the data. Let's say you want to build an autonomous car, so you want to classify images. So you show it a lot of images to know what not to hit when you're on the road. Or you want to classify data into how do I know somebody who's an anomaly for fraud? Or I'm going to give it some data and say, here's what I've done in the past, do a forecast for me. Sometimes I don't have the data. Just cluster the data into groups of ages because I know certain ages buy my product. I use that big data to increase my sales. Now, and I'm going to do this very quickly, is I'm going to go through each of these to show you just a little bit deeper on the business side what you would use them for. So classification, naive Bayes, is just a mathematical what you've done in the past. You've gotten some spam. It has certain words in it. As you learn those words, you can now categorize those in the future. You can categorize news. You could have sentiment. They use certain words. Spectacular, certain happy face. Terrible. You can give sentiment analysis. Or Wikipedia has one where they say, well, whether you're a male or female, let's see if it could calculate based on your height, weight, and foot size. It says, well, this person's 6 feet. Well, it looks like a male. 130 pounds, looks like a female. Up, foot size 8, it decides that it's a female. It may or may not be right, but it's using this. And there's also a Gaussian naive Bayes. There's naive Bayes and Gaussian naive Bayes. Gaussian is usually better to calculate that based on what's happened in the past. So that's one algorithm that does classification. The next one, you have logistic regression. You're looking between two values, a 0 or 1, Democrat, Republic. Are they going to default on their mortgage or not? Are they going to pass the test based on how many hours they've studied? Studied less than 1 hour, probably going to fail, because everybody has. Over 4 hours, probably going to pass. Logistic regression. Is that the kind of algorithm you need for classifying? Is it two things? Or is it like a decision tree like we saw with the lawyer? Or maybe you have multiple decision trees or so many cases, but you don't want to predict 6 ones and 3 zeros. That might be overfitting. You just want to make it a 1 if overall it's a 1. That's called random forest, to kind of smooth out some of the jagged lines. This is how I do it. And here's just an example. I don't want the line to go all over the place. I just want the smoothed out line. I want it to go like this. I want it to be nice and straight, also known as bagging. You can also do classification with a neural network, where we saw image classification earlier, but you could also do handwriting recognition or things like that, speech recognition, and it really emulates the brain or copies, what the brain and how it works with different levels of neurons that we have. And this is a great example from Healy from Finland, not too far from Norway there. But basically, if I look at a picture of a dog, maybe an eye comes up something, but if I have 2 eyes and I put those two together, or I see another picture of a dog, it might help me where this neural network in multiple layers mathematically will figure out whether it's a dog or a cat in this case. Now, deep learning does something where maybe I give it the features initially with machine learning and say, I want you to find eyes and a nose and a mouth to decide whether it's a dog or a car, maybe. But in deep learning, I just give it the picture and it figures it out. I could do that with Google's TensorFlow, which is integrated with Oracle as well. I could also do support vector machine classification, very fast, I find, to separate good and bad customers, with a line, but it does it as far. It makes sure the two groupings are separated as far as possible. I could also do classification of words for sentiment analysis. And basically it looks at the semantic relatedness of the words. Is it bad? Is it very bad? Extremely bad? The worst product I've ever had? Oh, not doing well. Spectacular, great product, amazing. And it looks at how they relate. So you could already see all the different ways I could classify two things. And depending on your business problem, you may just dig into one of these, because the settings for a model sometimes are very detailed and you want to tweak them a certain way. The next one, function, is clustering, and you could see the 3 algorithms below there. First one is k-means. Cluster my big data into 3 groupings. So k equals 3 in this particular example. There's an example where it's going through iterations in different iterations, it does it at distance based on where the centroid of the cluster is. Oracle, though, and you can do that with words as well. I could do it with different voters in different regions or states. But Oracle does it with density based. So Oracle says, instead of k-means where it's distance based for 3 groups, give me 3 groups, but I want the clusters density wise, because voters tend to live in cities and density is more important than distance. So I find Oracle's own algorithm, which took this a step further, called the O cluster, is much better. And then there's also an expectation maximization where it takes steps and it keeps, is this what I expected? And then it kind of tweaks it. The next one, anomaly detection, we saw there's some additional information, and I'm not going to read you the slides. It would take me, a day to present this if we wanted to go through every step of every algorithm. But I included for you so that if you truly want to go into these areas or a certain algorithm is very important to you, this allows you to do that. And we talked a little bit about that. Very big in the world of finance for fraud detection and security, but also for risk management. Looking at the outliers where there may be a risk in a certain stock and algorithmic trading. The next one, time series. People buy things at Christmas. It's a wonderful, best time of the year. But some things are different. They're not seasonal. They're more based on some event. So this is Austin, Texas, where Oracle is headquartered now. And these are different events. South by Southwest event where an Airbnb gets a much higher price, or an event called the City Limits Festival where there's a much higher price. And Airbnb sends this to the people who rent their Airbnb or their house to somebody to say, you should be charging more during these events. So there's also cyclical irregularities at different times that I would use these. Do you need a time series algorithm? Also used for time series, there's an exponential smoothing algorithm that, again, behind the scenes is math that may have been built over 50, 60, 70 years. Says not the stock price that's going up and down, but I want to exponentially smooth it to the red line, or double exponential smoothing to the blue line to smooth that out. And then the settings on the setting side again, older data might be weighted lower. How much lower should the older weighted? You'll decide those things and have different algorithms. Obviously, the blue line is called a Holt-Winters double exponential smoothing, but you're keeping the pattern, losing the noise. So is that the kind of algorithm you need? Or do you need regression? Linear regression, well, that's pretty easy. I could just use analytics for that. But what about GLM, generalized linear? Look where the dots are all over the place. This shows if people make over 50,000, as they age, they work less hours, but if they make, or if they under 50,000 is the red line, then over 50,000, well, they don't work as less of hours as the person who's making less. But coming up with the lines for this many dots, a little bit harder, or even harder yet. What if it's a sine wave? Maybe my business wants a sine wave, or maybe my business wants that to be smoothed out. And a change of the value of epsilon with this one, which is a support vector machine regression. You change the setting for epsilon to change what the graph is showing the person. Your business is going to be completely different than someone else's. Attribute importance, very easy. What are the attributes that make up my best customers? And if I can do that and show all those attributes, then I can very quickly find customers like them. But sometimes it's very simple, like a flip of a coin, heads and tails. And I just want the basic attributes. I don't want 50 attributes that tell me what make a best customer. I just want, one or two. So the minimum description link algorithm will take things down to the minimum, whether it's a heads or a tails. I don't want to know if the coin is perfectly formed. I just want the main things, the main attributes that make this customer important to me. Minimum descriptive length attributes. Or I could do KL divergence. These are two basketball players, the one on the right, and if you see it, it's in red, it means they make a lot of shots, and the one on the left doesn't make as many. And it looks at what the KL divergence of these two patterns is. And the amount of divergence is the surprise. The surprise may be a lot more losses if you get the person on the left, or if you change out the person on the left with the person on the right, maybe you get a lot more wins. But if they're identical, the divergence will be 0. And then there's also a couple others there as well. Association rules, market basket. What are people buying together? Very important in almost any business, not just retail. Somebody bought a certain type of item at your company that does magnet wire, let's say, maybe the second next thing they buy or customers like them buy attribute number two. But in the store, what are people buying together? Should I co-locate those items in the store? Should they all be together? Or maybe they're apart because I want them to walk the store a little more. But the a priori algorithm is what it gives you these association rules. Feature extraction takes out certain features, and they use this with eigenfaces. I know that's sometimes a controversial topic, but the idea is maybe you can apply this to other things, and we'll see with autonomous cars I might be able to apply. But the structures of the face are very limited numbers. So if I get the key structures, I don't have to look at as many of them. So it's much faster. But I could also be dogs and cats. But it's finding this eigenvector, or vector that's out there. I could also use it to see if someone's getting enough exercise by combining that and do sensor feature extraction, but look at those main features that are happening, not everything, just to see if they're walking or riding and how much exercise they're getting. Singular value decomposition is very important when I have a very large matrix. So for those of you that are in the math world, and if you're not, it's okay, because you just think of a matrix of what makes a good customer. Oh, it's how much they sell. Is it how much profit they make? Is it how often they buy? Is it how close they are to my company? Do they buy from my partners, and so on? And then I want to find a matrix that looks just like that. In Germany, the word eigen, and this is where eigenvalue comes from. Eigen means just like my very own. So if I like my car and I want to buy a new one, but I want one just like my very own, I want to find that eigen car, but that's maybe newer. Well, to find my eigenvector, I find that eigen customer maybe. So once I have the matrix, I want to start simplifying that matrix down to just the key pieces that are important, singular value decomposition. So I don't have to look at the big matrix. I can look at the much smaller, most important pieces to find my eigen customer. Then there's also text mining support in Oracle for all of these different algorithms. If your issue that you want or business problem is text related. As you know, there's a lot of analytics. If you are in the world of analytics, where I could put things to see different views, product manager, regional manager, but I could also partition all those tables. I could put those partitions in memory. I can make sure all that data is secure. So the advantages Oracle has as a database become even more important as I go into machine learning when I need things to be fast. And there's all kinds of statistical functions. Oracle has put out there 40, 50 years of statistical functions that I can leverage as well. So we have a lot of functions and a lot of things. What does your business need you to focus on? That's the key. And then how do you do it? At the end of the day, Oracle had this nice picture of machine learning functions. Am I classifying? Is it regression? Is it attribute importance? But I put this together. Find the business problem first. Then what's the function you want to do? Oh, you want to classify good and bad customers? Then which algorithm do you want to use? Take 60% of the data, test it. Test all the different algorithms that fall into a certain functional area like classification, then score them, or it's also means creating inferences on the other 40%, and then compare those. And here's just an example. I have some PL SQL. I'm using a decision tree, creating a model that does classification, go into a certain table, seeing if the customers will buy this affinity card, this credit card. And then I'm going to take those results on the other 40% of the table and say, what's the odds where the probability is over 50% that they bought it? And then I could see, did it work? And then I can go out to big data and use this algorithm if it's the best one. And these are just different ways people look at how good each algorithm is. And Oracle has a nice way to compare things based on lift, if you're familiar with it. And it means if I only have, let's say this line is 10% of the data, Some algorithms give you a lot of lift with very little data. It means it's giving you a lot of the answer. An easier way to look at a cumulative gain. With 10% of the data randomly, I see 10% of the answer. But with these algorithms, I'm up to 40% of the answer because of the math. And then data scientists will often put this on a receiver operating characteristic curve where it shows you the percentage. I'm seeing 60% of the answer with just, 5 or 10%. So as the curve goes up and to the left, very good. But Oracle said, you know what? Let me go back one. Just this upper left area. Oracle said, you know what? I'm going to look at all the algorithms for you. I'm going to look at all the features for you. I'm going to automatically fill in the missing data. And I'm going to automatically tune the model, tell you which algorithm is the best one, let's say for classification, since there's 7 different ones I could do. So I said, okay, I built this myself using autonomous database. Took me, I don't know, day and a half, 2 days to build this. It's 50 to 50 plus pages, although I put a lot of graphs in there and that takes a lot of space, but I'm going to try it with auto machine learning. So I did this, of course, the day it came out, which was just in March. And I said, I'm going to do classification based on this table to see if the customers will buy an affinity card. And then I said, yeah, use all these different algorithms. These were in my settings. And then I said, okay, run it. Ran it. It created the notebook, 4.5 minutes. What took me 2 days took Oracle 4.5 minutes. And then it wrote the algorithm for me. In this case was in Python. So not only can I now build algorithms if I know which ones to use, I could have Oracle test them for me and build the entire notebook for me if I know what I'm doing. Saves you money, saves you time. And I mean, saves you a lot of time. And maybe it could make your company money by finding similar customers. In 21C, they added a couple new ones, XG Boost, so another classification algorithm and another anomaly detection one. The MSET SPRT looks for very subtle anomalies without causing false alarms. How much are algorithms already out there? There was somebody who all they did was went through and read all the healthcare articles on PubMed and said, are they ever talking about an algorithm? And which ones are they talking about? And the answer was they're talking about support vector machines a lot. Why is that? Well, maybe because it does anomaly detection. They're talking about neural networks a lot. Maybe it's because it does image classification. So people see it coming and they're talking about different things that can help. You should be applying this to your business. There's all kinds of choices. You need to see, do I have the data, supervised learning? Don't I have the data? I can also do gaming where I'm having it compete against itself. That's another one. But are you trying to predict the traffic? Are you trying to find fraud? Do you need a support vector machine, one class support vector machine, or is it medical diagnosis where you need image classification? Or maybe it's security. Here's different things people are using it for. Security's big. Or you could just have fun with it. This is somebody who said, what would Marie Antoinette look like if she lived today? What would Henry VIII look like if he lived today? Use something called GANs to find all that out. There's also robotic process automation. And this is a company that gave me a few slides on it, but I wanted to show you that the robot working with you is making you more advantageous, obviously, because you can do 2 or 3 times or even 10 times the work you did before. And they work all the time. They don't get sick. They don't take vacations. But they could do things like filling in forms. They could fill in Oracle forms for you, read and write to a database, access other applications, open emails, read those emails. Think of the machine, but the machine learning's already built into the product. This product is UiPath, and it goes to all these different products to automatically fill it in for you. So the person just has to maybe double check it only, making them much faster or better. Number one job out there, AI machine learning specialist. You could see the different things. You may, after watching this talk, be good enough to get a job. Who knows? If you really take the time to build a few notebooks. Number one language for machine, Python, TensorFlow, image recognition. Well, with Oracle, I can do SQL or Python. Now I could also do R, I could do any of those. And I also integrate TensorFlow. I could also integrate Jupyter notebooks. I could use what Oracle has as a default, which is Zeppelin notebooks. This is Oracle Machine Learning for Python, OML for Pi, it's called, and how they do it. I'm not going to go through it, but here's a rough idea of how it looks. We also saw the earlier notebook that it did with automatic machine learning for me. You can also use Oracle Analytics Cloud, very nice way to build nice graphs, different sales in different quarters, group the customers by different colors. The width is how much profit. Is very intuitive. It's easy to see what the answer is. But now they've added machine learning into that product. Or I could use the k-means clustering algorithm, and I just say k is equal to 5, and it breaks it into 5 clusters. Not very hard. Give it the x, y columns, and it quickly tells me the answer. Now, this product does have some cost. And there's my email if you need anything. Data, though, becoming very valuable. Data-driven organizations are more likely to acquire customers. They're higher valued on Wall Street because they can retain customers because they understand their customers. They're good at finding new customers. And you could see why by the algorithms we've seen. Big data comes at you very fast. It has different values, it has different varieties, it has different speeds, it has different truths or veracities. Isn't it nice that Oracle has built a converged database to handle all these different types? So an advantage of Oracle is that I can look at relational, JSON, key value graph, spatial, all the different types of data. Very nice. And with Internet of Things, there's just going to be more data coming at you. Better get an Exadata. We used to look at what happened or why it happened. Then we want to know what will happen. Now it's what's the best thing that could happen. Prescriptive analytics is prescribe to me what I need to do the best thing. Now, if you know Oracle in this image, Gustavo was saying you need to know more than Oracle. You need to know some of these other things, but he showed you quickly that Terraform, it's like learning just another feature of Oracle, or Ansible, like learning, just another part of Oracle that you've done before. You can use Oracle as your secure portal to go to things like Hadoop and other NoSQL databases or MySQL or whatever. If you're a DBA, though, you're very important because when I look at the percentage of time allocated to machine learning project tasks, data scientists, 20% of them. DBA, 80%. The DBA is the most important person in machine learning today. And because not enough of them are there, it's becoming a little bit of a problem. As I add more data, that curve goes to the upper and the left to where I want it to be, where I can predict the answer very, very quickly. That's why the DBA is so important. Number 8 job, data engineer. Works as part of the analytics or machine learning team, it should say, providing data in a ready-to-use format. They are the key person. Shouldn't be number 8, it should be number 1. They do 80% of the project. People are just finding that out. I did an article for Forbes where they interviewed me on DBAs, and I said they are the most overworked because they manage too many databases, but not efficiently utilized. They should be in the machine learning area, and they should be using autonomous database to help manage the databases, and they'll be much more valuable to a company. Notice 38,000 C-level people, CEOs, CFOs, CIOs saw that. How do I make machine learning fast? Well, with Oracle Exadata, I could use in-memory. I could make it available, recoverable. I could partition it. I could put that in memory, the partitions in memory. Use things like storage indexes where it automatically builds indexes for me. Do columnar flash. A lot. Oracle also put it into their own products. And I just give you a brief taste of that. In Oracle manufacturing, Oracle already tells you these are areas you're going to have a quality problem, maybe because the pH level isn't correct, or you're going to have a yield problem. Maybe you didn't had an issue with the supply chain or something like that. They also have a market basket. In the market basket side in Oracle BI, that will tell you who your bargain hunters are, big spenders, the loyal customers, what they're buying together. As a CFO, Chief Financial Officer, it'll tell you what the optimal discount you need to get a certain amount of revenue so that you can do prescriptive analytics and prescribe the numbers you need to hit and configure price quote. And human capital management will tell you which people are most important, what key thing you did, maybe you gave them more vacation or more money. And I could tell you somebody who's very important, what you've done in the past year, and then do a what if scenario to see if you paid them a little more, gave them more vacation, if they'd get better. So Oracle has put machine learning in their products. And if you put together all the parts of machine learning, you'll get even better answers out there. They've also put it into their customer experience or CX products. Here's an example on sales where you have a win percentage and they tell you some advice on how to get better wins. They've also included a chat bot where you could build a bot that, you know, they bought item one and, you know, customers that were like them bought item two. So you say, you just have a chat bot to go out there and tell them, oh, check out item two. And you can also get them to do multilingual chatbots. But I always say a chatbot is simple for the person using it. I want to check my bank balance. But behind the scenes, it's very complicated, kind of like a movie where maybe you see what's on the screen, but behind the scenes, a lot is happening. But Oracle's build this nice bot that's very, very easy. I think it's like learning a new feature of Oracle on how to do it, or learning some application that somebody's built, and it might take you a couple of days. Also integrates with things like Facebook Messenger and other things, and also gives you nice graphing. But if you go into chatbots, not very difficult. Now, if we look at AI, and things are sometimes feel very overwhelming on how much is happening, but machine learning, and if I use auto machine learning, I can do machine learning very quickly. I can use things like deep learning to very quickly do image classification. Robots are I just need to put that machine learning brain into the robots, and now robots can help automate things for me so that each person that works in a job is that much more important and is that much more effective. As we look to the future, though, things are getting very crazy. I call it the twilight zone, but you can leverage robots right now. The database in robotics, it works today. Is your company doing it? Here's somebody who are their sushi restaurant. They bought a Pepper the robot in the sushi restaurant to seat you at a table. They could pay everyone else more now because they need one less person. How to connect Pepper? Well, I can connect Pepper with all kinds of Oracle products if I want to. I could also connect Oracle with things like Facebook Messenger, with WhatsApp, with Alexa, with Siri, you name it. Are you leveraging that? And I do that. I use Pepper through a virtual assistant to see what people are saying to Pepper. I could also leverage the database with virtual reality, with mixed reality, with augmented reality. Wouldn't it be nice if we had a pandemic and I had a product that where people could just put their iPad up and see how the product looks on the shelf, since, you know, I don't have that. Well, I could have done that with Oracle if I built it. I could also integrate HoloLens, Microsoft HoloLens, to see what's inside this truck piece by piece. And am I back ordered? Is the supply chain missing certain things where I need to order it well in advance? I could leverage the database, GPS, robotics all together. IoT, all the different things. I'm being watched. I could watch the products, but the products are watching me too. What about the hackers that are out there, they're going to leverage the database and IoT and all of these things to maybe they're going to hack my car. As Black Mirror would say, he's a coder, he's fallible. I always notice they don't say she's a coder, she's fallible, just he is. He's fallible. She writes perfect code. But it used to be viruses, social engineering. Now people are going to hack, your augmentation or an implant if they have it. Security becoming the top AI app to stop those security intrusions, find those anomalies. And then also, if you want to build a great company, make it magical. Some once magical companies became manic. Don't make your chatbot send me an email every 5 minutes, or it's manic, or don't send it to your partners who start spying on me. That's toxic. Build that magical app. You'll find you'll replace the ones that aren't magical. But use Oracle because the security is really there. Some of these products haven't been around as long as one of Oracle's security products, let alone the 30 or 40 that are in there automatically. It used to be all about technology coming, big data, cloud computing. Then all of a sudden in the Gartner hype cycle, it was about autonomous vehicles coming and smart robots and my connected home. Now robots are beyond science fiction. Can't even make a movie. It's going to all about implant technology, faster cloud, brain implants. This guy is quadriplegic and he can take a drink just by thinking about it. 2016, it was all about cognitive type of stuff and brain computer interfaces. It's because things are advancing as we move from 4-bit to 8-bit, 16, 32. The amount of directly addressable memory just keeps going up exponentially. I put it in miles an hour and you could see how fast it was when we got to the internet. I was like jumping to 65,000 miles an hour. Then now, today, we're jumping to 300 trillion. Future, even higher. 2018, the digital twin. It's you and your autonomous DBA taking care of the other databases for you. Quantum computing coming. 2020 hype cycle. Notice machine learning is here. It's not even at 5% is here. 5% of the people using it is here. 30% of the people using it out here on the right. You're at the leading edge if you're doing machine learning. And notice all generative AI, digital humans, quantum machine learning, AI-driven innovation, everything is driving toward AI and machine learning. Quantum computers, if you've never seen one, this is D-Wave's quantum computer. It's got to be very cold. Here's a little more about entanglement and how you can have it a 0 and a 1 at the same time, but I'm not going to go into that. But quantum computers, there's a great book on it, Quantum Entanglement. Maybe this is how prayers works, how you're entangled with heaven on the other side. Who knows? Final thoughts. The world is changing fast. Star Trek used to be very, very, very leading edge. And cell phones, I think we have that taken. William Shatner, Captain Kirk, has now been to space. It's becoming much faster. Do you see this coming? Are you leveraging it? The goal, what's important now is to understand there's innovation, there's disruption. Are you leveraging the pieces either that you could build with autonomous database or that Oracle has already built in the applications? Are you building chatbots to help? Are you starting to integrate robots? Because things come to those who wait, but only the things left by those who hustle. Oracle's rarely caught from behind. And there's my email if you need to send me an email on anything or need help on anything. But I want to thank you. I don't know if we have any questions. I didn't see any. I know it's a lot to see, but this is where things are coming. And are you guys still there? Can you still hear me?
Yeah, we can still hear you. If you have any questions,
sure.
Feel free to raise your hand in Zoom, and I can give you the right to talk.
Yeah. And this is notice the beginning. I'll just go to the very first slide, is an exposure to all the products that are in Oracle and machine learning. But if you use Oracle, let me just give you a few end slides. that was way back, is Oracle has been number one since they came out, still number one. Things come up and down. Some things that are newer, people say will be the biggest, but Oracle, Microsoft, IBM have really stayed up there. The only one that's really come into play lately is Amazon. So that's a great slide as well that I skipped. Anyway.
Cool.
All right. Well, thank you very much for having me, and you guys have a great day.
Yeah, thanks for talking, and I really appreciate not just talking about it, but showing such direct examples like you did. It's
Sure.
it's appreciated, makes it easier to learn more in detail later.
It is the future, and if you understand this stuff, you will build it.
Yeah. Thank you so much, Rich.